If your Toyota Corolla Cross is running hot, taking forever to warm up, blowing lukewarm air from the heater, or throwing a cooling system code, it's really tempting to think, it's just the thermostat. Swap it and I'm done. And sometimes that's true. But just as often, a simple thermostat job turns into repeat overheating, weird temperature swings, or a persistent warning light, because one small step gets skipped, and modern cooling systems punish shortcuts. This is a practical, real-world walkthrough of thermostat replacement on Toyota Corolla Cross, focused on what actually goes wrong, how to tell thermostat symptoms from other problems, how to avoid leaks and broken housings, and how to refill the system so you don't trap air and create the exact overheating you were trying to fix. First, a quick reality check. A thermostat is basically a temperature control valve. When the engine is cold, it stays closed so the engine warms up quickly. Once the coolant reaches its target temperature, it opens and lets coolant flow through the radiator to shed heat. If it sticks closed, the engine can overheat fast. If it sticks open, the engine may run too cool, warm up slowly, and the heater may feel weak at idle or in cold weather. But here's the catch, those same symptoms can also come from low coolant, a bad radiator cap, an air pocket, a cooling fan issue, a clogged radiator, or even a sensor reading wrong. So before you unbolt anything, you want a couple of simple observations that point you toward the thermostat specifically. Start with coolant level, but do it safely. Never open the radiator cap or any pressurized part of the system when the engine is hot. If the car has been running and you're not sure, wait until it's fully cool. Then check the coolant reservoir level and look for obvious signs of leaks, crusty residue around hose connections, wet spots under the car, or a sweet smell after parking. If the reservoir is empty or low, don't assume the thermostat caused it. A thermostat doesn't use up coolant. Low coolant means a leak or a previous bad fill, and low coolant alone can cause overheating and no heat complaints. Next, think about the pattern. If the temperature climbs quickly from normal to hot, especially at highway speeds, that can be thermostat stuck closed, but it can also be low coolant or a flow problem. If the temperature is mostly okay while driving but rises when idling in traffic, that leans more toward cooling fan operation, airflow, or radiator efficiency than the thermostat. If the engine takes a long time to reach normal temperature and the heater never gets truly hot, that's classic thermostat stuck open, but it can also be a coolant temperature sensor issue or a system that's been refilled with trapped air. One of the simplest no-tools checks is the radiator hose behavior during warm-up. With the engine cold, start it and let it idle. Carefully feel the upper radiator hose area as the engine warms. At first it should stay relatively cool while the engine warms internally. Then, when the thermostat opens, you'll feel a noticeable change, the hose temperature rises as hot coolant starts flowing to the radiator. If the hose warms gradually from the very beginning, that can suggest the thermostat is stuck open. If the engine temperature climbs but the upper hose stays cool for too long, that can suggest the thermostat isn't opening, or that coolant is low and not circulating properly. Be careful here, fans can turn on unexpectedly, and hot components can burn you. You're not trying to prove a lab theory, you're just looking for a pattern that makes sense. Also pay attention to the heater. The cabin heater is basically a small radiator. If you have no heat and the engine is overheating, that often points to low coolant or an air pocket, because the heater core is one of the first places to stop flowing when the system isn't full. A thermostat stuck closed can also cause overheating, but you often still get some heat early on until things get extreme. If you have weak heat at idle but better heat when revving the engine, that's a classic sign of air in the system or low coolant, because higher pump speed pushes coolant through pockets that otherwise block flow. Now, when should you not drive the car? If the temperature warning comes on, if the gauge is climbing rapidly, if you see steam, or if you're losing coolant, don't just make it home. Overheating can warp components and turn a manageable cooling issue into an engine repair. If you must move the vehicle a short distance for safety, keep it minimal and shut it down if temperature rises. Assuming your symptoms still point toward the thermostat, let's talk preparation, because this is where most people either set themselves up for success or create a mess. Parts first. The thermostat is not a place to gamble on the cheapest option. The temperature rating and the way it opens matter, and cheap thermostats can stick, open late, or behave inconsistently. Ideally, use an OEM thermostat or a high-quality equivalent from a reputable brand. Many thermostats come as a unit with a seal, or they use a separate O-ring. That seal is not optional. Reusing an old flattened O-ring is one of the most common reasons people end up with a slow leak that only shows up after a few heat cycles. Coolant matters too. Toyota vehicles typically use a specific long-life coolant chemistry. Mixing coolant types can create sludge, reduce corrosion protection, and cause long-term problems. If you're not sure what's in the system, the safest approach is to use the correct Toyota spec coolant and avoid mixing universal fluids unless you're absolutely certain it's compatible. If you're only draining a small amount, you still want to top off with the same type that's already in there. If the coolant looks rusty, oily, or contaminated, that's a bigger conversation than a thermostat swap. Tools and supplies. You'll want basic hand tools, a drain pen, rags, and something to catch spills. You'll also want a way to add coolant cleanly. A spill-free funnel can make bleeding easier. If you have access to a scan tool that can read live coolant temperature, that's a huge advantage, because the dash gauge is often damped and doesn't show small fluctuations. But you can still do the job without a scan tool if you're careful and observant. Safety is not negotiable. Coolant under pressure can cause serious burns. Work on a cold engine. Keep coolant away from pets and children, it can be toxic. Clean spills immediately. Now, where is the thermostat on a Toyota Corolla Cross? The exact layout can vary by engine and model year, and some modern setups integrate the thermostat into a housing assembly. But the general rule still helps. The thermostat is usually located where the upper radiator hose meets the engine, at or near the thermostat housing. If you follow the upper radiator hose from the radiator back toward the engine, it typically leads you to the housing that contains the thermostat. Sometimes you'll need to remove an engine cover or an intake duct to see it clearly. Take your time here. Don't start disconnecting random hoses. Identify the housing, look at how it's bolted on, and notice what's attached to it: small coolant lines, sensors, wiring connectors, or brackets. Here's the first small step that people skip and regret later. Before you remove anything, take a clear photo of the area from a couple angles. Hose routing, clamp orientation, connector positions, these details matter when you're putting it back together and you're tired and coolant is dripping. A 10-second photo can save you an hour of second guessing. Once you've located the housing and you're confident you can access it, you need a drain strategy. You don't always have to drain the entire cooling system for a thermostat replacement, but you do need to lower the coolant level below the thermostat housing. If you open the housing while the coolant level is above it, you'll dump coolant everywhere, onto belts, connectors, and the ground. Some people try to clamp hoses to avoid draining. That can work in certain situations, but it can also damage hoses or still leave you with a spill. The cleanest approach is usually to drain enough coolant from the radiator drain point, if accessible, into a clean pan. If the coolant is relatively fresh and clean, you may be able to reuse it, but only if you keep it clean. If it's old or contaminated, plan to replace it. With coolant drained to a safe level, disconnect anything blocking access. If there's an intake duct, loosen clamps and move it aside. If there are electrical connectors on or near the housing, disconnect them carefully by releasing the lock tab, don't yank on wires. For hoses, use proper hose clamp pliers if you have them, or carefully compress spring clamps with pliers and slide them back. Twist hoses gently to break the seal before pulling. If a hose is stuck, don't pry aggressively with a screwdriver against the plastic neck, that's how necks crack. Work it patiently. Now you're at the housing bolts. This is where another common mistake happens: overconfidence with torque. Many thermostat housings on modern cars include plastic components. Over-tightening can crack the housing or strip threads. Under-tightening can leak. The right approach is control tightening, evenly, and if you have the correct torque spec for your exact engine, use it. If you don't, tighten snugly and evenly, and stop when the housing seats properly. Don't add a little extra for safety. Extra is not safety here. As you remove the housing, be ready for some coolant to spill. Keep the drain pan positioned and have rags ready. Once the housing is off, you'll see the thermostat and the sealing surface. Before you pull the thermostat out, look at its orientation. This matters more than people think. Many thermostats have a small bleed valve or jiggle pin that's designed to let trapped air pass during filling. If your thermostat has one, its position is important. Often it should be oriented toward the top so air can escape. If you install it in the wrong orientation, you can trap air, and then you get temperature spikes, poor heater performance, and the feeling that the new thermostat didn't fix anything. In reality, the system just can't purge air properly. Remove the old thermostat and seal. Inspect the old seal. If it's flattened, hard, or torn, that's your reminder not to reuse it. Inspect the housing and the mating surface on the engine. You want it clean and smooth. Don't gouge aluminum surfaces with sharp tools. If there's old gasket material or residue, clean it carefully with a plastic scraper and a clean rag. Any debris left behind can create a leak path. Compare the new thermostat to the old one. Same size, same shape, same depth, same style of seal. If something looks different, stop and verify you have the correct part. Installing the wrong thermostat can cause endless confusion because the car may sort of run, but never quite right. Install the new thermostat in the correct orientation. Make sure it seats fully. Install the new O-ring or gasket exactly as designed. Some seals sit in a groove on the thermostat, others sit in the housing. Make sure it's not twisted or pinched. A pinched O-ring can leak immediately, or it can leak only after heat cycling, which is even more annoying because it looks fine at first. Reinstall the housing. Start bolts by hand to avoid cross-threading. Tighten evenly. If there are multiple bolts, bring them down gradually so the housing seats flat. Reconnect hoses fully and position clamps correctly. Reconnect any electrical connectors until they click. Reinstall any intake ducting or covers you moved. Now comes the step that separates a clean thermostat job from a frustrating one, refilling and bleeding the cooling system. This is the part that gets skipped, rushed, or done the old way, and it's the reason people end up with a car that overheats after a thermostat replacement even though nothing is technically broken. Air is the enemy. Air pockets can prevent coolant from circulating, can keep the thermostat from seeing the correct temperature, can cause the heater to blow cold, and can create sudden temperature spikes. Some engines are more forgiving than others, but you should assume your system needs a careful refill. Refill with the correct coolant mixture. If you're using concentrate, mix it properly with distilled water unless the coolant is premixed. Don't rely on tap water long-term, minerals can contribute to deposits. Fill the reservoir to the appropriate level. If your system has a radiator kept full point, fill there as well, but only on a cold engine. A spill-free funnel can help because it raises the fill point and allows air to burp out without making a mess. With the funnel in place, start the engine and set the heater to a warm setting so coolant can circulate through the heater core. Let the engine idle and watch the coolant level in the funnel or reservoir. As air purges, the level may drop. Add coolant as needed to keep it from sucking air back in. As the engine warms, you're watching for a few signs. 1. The heater should start producing steady warm air. 2. You should eventually feel the upper radiator hose get hot when the thermostat opens. 3. You may see bubbles come up as trapped air escapes. Small bubbles early on can be normal. A constant stream of bubbles that never settles can indicate another issue, but don't jump to conclusions immediately, some systems burp for a while. If you have a scan tool, watch the coolant temperature rise smoothly. You're looking for a steady climb, then a point where temperature stabilizes as the thermostat opens and the radiator begins shedding heat. The cooling fan should cycle on and off as needed. If you don't have a scan tool, you can still observe, the temperature gauge should reach its normal position and stay there, the heater should be consistent, and you shouldn't see the reservoir level doing wild swings after the first few minutes. Once the thermostat has opened and you've had a few fan cycles, shut the engine off and let it cool completely. This is another step people skip. Cooling down allows remaining air to migrate and the coolant level to settle. After it's fully cool, recheck the reservoir level and top off if needed. Then inspect for leaks around the thermostat housing and hose connections. Look for dried residue after a test drive too, because some leaks only show under pressure. Now, how do you confirm the fix without guessing? You want normal warm-up behavior, stable operating temperature, and consistent cabin heat. If your original symptom was overheating, you want to see that it no longer climbs under the same conditions that used to trigger it. If your original symptom was slow warm-up or poor heat, you want to see quicker warm-up and stronger heater output. If you had a check engine light related to coolant temperature, it may clear on its own after a few drive cycles, or it may need to be cleared with a scan tool depending on the code and the vehicle's logic. But don't clear codes as a way to see if it comes back, without verifying coolant level and bleeding first. Clearing the code doesn't fix the condition that caused it. This is also where it's worth saying out loud, if you do thermostat replacement on Toyota Corolla Cross perfectly and the car still overheats, don't keep throwing parts at it. Recheck the basics first. Is the coolant level truly full after a complete cool down? Are there any leaks? Is the radiator kept sealing properly? Are the fans actually coming on when the engine is hot and the AC is on? Is the heater output stable? A thermostat is only one gate in the system. If another part is failing, a new thermostat won't mask it. A few common mistakes are worth calling out because they're so easy to make. Installing the thermostat backwards sounds impossible until you realize some housings make it physically possible. If the thermostat doesn't sit the same way the old one did, stop and compare. Another mistake is scraping ceiling surfaces aggressively and creating a groove that leaks forever. Another is over-tightening bolts into plastic. People hear coolant leak and think tighter is better. It isn't. Another is mixing coolant types because coolant is coolant. That can create long-term issues that show up months later, far away from the day you did the repair. And then there's the big one, not bleeding the system properly. You can do everything else right and still end up with an engine that runs hotter than before because an air pocket is sitting in the wrong place. That's why the job is more than a swap. The thermostat is the easy part. The refill is the real repair. One more nuance, some newer vehicles use more complex cooling strategies, and in some cases the thermostat may be part of a larger assembly or interact with electronically controlled components. That doesn't mean you can't replace it yourself, but it does mean you should pay attention to connectors, sensors, and any hoses that look like they belong to a bypass circuit. If something doesn't match what you expected, don't force it. Verify the part and the layout for your exact engine. So here's the practical takeaway. If your symptoms match a thermostat problem, replacing it can absolutely restore normal temperature control and heater performance. But the reason people get burned by this job is really the thermostat itself. It's the seal, the housing, the orientation, and the air purge. Treat those like the main event, and the thermostat swap becomes straightforward. If you want one sentence to keep in your head while you work, it's this: thermostat replacement on Toyota Corolla Cross isn't finished when the bolts are tight, it's finished when the system is full, purge of air, leak-free after a full heat cycle, and stable on a real drive. That's the difference between it runs and it's fixed.